So I've decided to embark on another certification, the SPRI, Implementing Cisco Service Provider Advanced Routing Solutions. So I realized when I was doing my certification that there's an element of my learning that I'm missing out on, and that is the element of teaching someone else what I've learned. So I've decided to do YouTube videos on everything I've learned. And what I've also decided to do was to implement the skills that I learned from my SPRI examination, or the automation skills, and adapt them to this new certification. So I'm going to create a new course. So great time for me to make me a more modern engineer, to get a deep understanding of the protocols, at the same time have a deep understanding of the application side of it and the automation side of it. So I'm going to release my first video today. It will be basically configuring BGP adjacency with Ansible and Netconf-Yang. So each and every single week, like I said, I'll be bringing out a new video based on the constant calendar during the week. So I'm going to start from my basics because I haven't really done any learning on networking, traditional networking in a long time. So I'm going to start with the basics of BGP, ISS, OSPF as I go into newer topics like segment routing. So thank you, enjoy the video and enjoy the SPRI series. Thank you. Okay, so today we'll be configuring BGP neighbour adjacency using Ansible and Netconf-Yang. So basically we're going to use Ansible to configure the interface configuration, and then we're going to use Netconf to configure the BGP adjacency and the BGP routing process. So basically this is the topology. So we got 3 ISXA routers that we want to configure. We want to configure interface gigabyte 1 and gigabyte 1. On ISP1, gigabyte 1, gigabyte 2, and gigabyte 3 on the R1 or customer router. Then also configure gigabyte 2 on ISP2. So all this will be done using an Ansible playbook. So basically, we're going to configure the interface, we're going to verify the configuration, and we're going to test reachability using Ansible, and then also going to save configuration using Ansible. So no, we do not want to enter the command line. We want to approach this from a modern automated approach to network management. So again, after we're done with that, the second thing is configuring it. Since now our interface is now reachable, we can now configure GPI adjacency between them. For that, we're going to use a Python script, which will be using NC client to run netconf, and we're going to use the proprietary Cisco BGP-Yang model to configure and to verify configuration data. Then we're also going to use the operational data model to obtain operational data. The one that we're particularly interested in is the state of our neighbor. Is it established or is not established? So that's what we're going to be doing. So just to give you a nitty-gritty of what we're doing, you can see 3 routers here. These are the interfaces that we want to configure on those routers: the IP address, the mask, and the description. So this is kind of what we want to do here. Then also what we want to do is show IP interface breadth and check reachability using Ansible playbook. And after that, we save the configuration if we realize that everything is up and running. And for GPG adjacency, we're going to be using Netconf-Yang. Like I said, we're going to be using the proprietary Yang model, and we're going to be using the module, the BGP module in the Cisco proprietary Yang model. So basically, we're going to create a BGP routing process. Then we're going to set the BGP router ID. Then we're going to configure the neighbor. Then what we also want to do is configure the description of the neighbor. Then again, we want to verify the configuration, verify the state between the adjacencies, and we're going to save the configuration. So basically, I wrote 3 scripts. One is to configure and verify configuration. The other one is to verify the state between the adjacencies where we're using a different model, and the other one was to save configuration. So basically, why I split it into three. Okay, like I did with this one, to want to configure gigabyte 1 with this IP address, and again gigabyte 2 with this IP address, and also want to configure gigabyte 3 with this IP address on the customer router. Basically, I've already configured a few things. Yeah, I've configured Netconf-Yang, I've configured SSH because Netconf runs on SSH. Then I've configured Netconf-Yang, so I've enabled Netconf-Yang on these routers. I've also created network. Like you can see, it's called created to the dev box. This is my Ubuntu virtual machine where I'll be running my scripts from. So it's commands, and it should be configuring BGP. So basically, the first step is obviously want to configure our interfaces and check if they're reachable. For us to do that, we're going to use the Ansible playbooks. Ansible for that. So we see the configuring interfaces Ansible. Okay, lists. So basically, we've got three scripts here: configure interfaces.yaml. Then we've got our group files, which basically contains our username and passwords for our devices, and our host files. Host files make it a bit interesting. Let me cat to host files 192.168.42.82. So 42.82 YAML. Like you can see in our host files, we've got all the variables that we need to actually configure the IP addresses. Like you can see, I created three dictionaries. We put the name of the interface that we want to configure for 192.168.42.82. That's our customer router if you remember our topology. So we've got the description, and the remote IP is used. This IP address will be used for when we want to check reachability. So it's going to ping 150.1.1.1. This should be ISP1, and it's going to ping 200.1.1.2. This should be the host machine on the local area network, and 150.1.1.5. This should be ISP2. So it's going to create these interfaces, and then once we get to the module that actually does the reachability test, then it's going to use these variables. So this is where I'll be storing where I stored my variables. Then I created, for the group files, I actually created a group in the Ansible config. So it will be sudo cat etc Ansible. So you can see I created a port called BGP configuration, so I can configure all these routers at the same time. All right, so clear. So the group files contains the group files is the one that contains the credentials for the devices. So now we've got the first playbook, configure interfaces.yaml. Just to explain what it is. So basically, it runs certain tasks. First is configuring the IP address on the interface. Like you see, it's getting our variables from the host files. So configure the name of the interface and then the address. Then we're going to want to enable and insert a description. So we're using a different module, which is iOS interfaces. Then again, we want to verify the configuration. So we run a show IP interface brief, store it as a variable. Then we debug that variable so that we can see it on our command line. Then we have to test reachability. We ping with the ping module for the iOS devices. Then again, we store it as a variable and we see the results in our at the end of our script. Clear list. So now again, cat save configuration.yaml. This is the one that we're going to use to save the configuration if the configuration is done properly and our devices are reachable. All right, list. So now we can just run the playbook. Okay, let's see what's going on here. Alright, seems like everything passed. The configuration has been changed once I'm particularly test reachability. Right, so IP addresses have been configured and it seems like we are reachable. So this is the configuration and it's basically in line with our plan. So now since that is done, now what I want to do is save the configuration. So like I wrote Ansible playbook for it, then save configuration. Right, clear, and we're good. So now we got to see the like list. Now we see the configure BGP list. So now when you enter a virtual environment, so our scripts work, we activate, activate our virtual environment. So what we write is Python configuring BGP and py. Alright, before we run the script, let me just give you just a few minutes just to explain what's going on here. So basically we've got our variables to contained in the config variables.csv. So there you can see we've got our IP address of our device, we've got our router ID, our local autonomous system, we've got the neighbors, remote IP address, we've got the neighbors autonomous system, and we've got the description of the neighbor. So these are all the variables that we need to set up. We need to check the neighbor state, and we need to save the configuration. Basically for neighbor state and saving configuration, I think the only IP address we'll be using is, the only variable using is the first one, the IP address of the device. Otherwise, the ones which are going to be using all these is probably configured in BGP. So like I said, I used the proprietary Yang model. So I can't remember the name by head. So we have to get into config template.xml. So basically, this is the model that I use, the ISXC, Cisco ISXC BGP Yang model. So basically, this is under their native models. So this is the one that I use for the configuration and the verification of the configuration. Then I use the operational parameters. The Cisco ISSC BGP operational data, top 10 operational data. That's when I wanted to check if the BGP neighbors are established after the configuration has taken place. Then for saving config, I used an RPC. So I dispatch RPC cat saving config dot XML. So I'm not really going much. I'm going to draw much into the script that I run and what it means. So what I'll try to do is I've already put the script on GitHub, so I'll comment on the Python script just for anyone who's interested in looking at it to see what was actually going on. And then I'll just save it on GitHub and I'll put the link description at the bottom of the video to where the script is contained. So the first step we actually want to configure our BGP peer. So for us to configure our BGP peer, it's just as simple as Python configure BGP peer.py. Then we run our Python script. So it should configure all peers. Let's see how long it takes. Okay, you are getting okay. That symbolizes good news. So now, yes, yeah, it does seem like it's good news. So basically, this is the configuration that has been actually on the device. Okay, why is it taking so long? Alright, anyways, we're waiting for it. Alright, so the configuration is done and taken out. This is the configuration which is actually on the device. Like you can see, I'm not sure, like, this is the part that I couldn't. Okay, it's basic Python, but basically it comes in as a list. Then I try accept statements, so like it's looping through. So anyway, basically, like you see that the remote IP address that is preset from a neighbor is 1.1. The remote autonomous system is this, and the description is this. So basically, it should be done on about 3. Yep. So this is the last one. All right, cool. So now that's done. So this is the IP, the configuration that has been sent. So now since that's done, so basically with what I tried to do was use the open config model. So what I would get is an RPC OK saying that the configuration has been changed, but when I went to the device, there wasn't show running config. So that's why I added the defaulting back to the native Yang model. But ideally, I would have liked to use the open config because it's more of an agnostic. So basically, now that this configuration is done, I want to check the state of our neighbors by running the Python neighbor state neighbor state.py. All right, as long as we're getting established, we should be happy. So this is for 42.82. So that means that it's the connection is established for all our routers. So 42.108 is established, 42.82 is established, and 42.95 is established. So again, this is where I got it wrong in my script. So what was actually happening is that because for 192.42 ISP1 and ISP2, there's only one neighbor that I created. But then when I was obtaining the operational data, it was coming, it's supposed to be a list from what is written on the Yang model, but it comes in with so when I wanted to look through the list, I wasn't getting the parameters for 42.95 and 108, that's ISP1 and ISP2. I wasn't sure why it was giving me an error, but for 42.82 it was actually looping through the list. So what I basically did was I did a try accept a statement to accept the error. So instead of treating it as a list, I ended up treating it as a dictionary. But what happens is that for 42.95 and 42.108, that ISP1 and ISP2, it just gives me this long list of confirmation messages. I was like, okay, what's going on? But anyways, it's just a small thing that I'll probably have to fix for my scripts. I'll try to fix it as we go along with the BGP series. And then clear. So basically now the last thing will be just saving the configuration. We're done. We didn't even go into our command line. All we did was from our development environment, we configured our device, we verified the configuration, and we verified the operational status. So that is like the modern approach to managing networking devices. So, like I said in my short introduction, is that every single concept that I'll be learning in my SPRIs, I'm diving deeper into my protocols. I'll try my best to automate and either put the script on GitHub if I don't have time to make a video, or if I do have time to make a video, I'll share the video and then I'll share the script on GitHub, so that for my sense, I become a more well-rounded engineer who understands the modern approach and appreciates the use of the CLI. At the same time, I also get a deeper understanding of the protocols. So my goal is to be a network automation engineer in a few years' time. So by the grace of God, that will happen. So I think we're done for the day. I think probably the last thing is just to verify on the device. Okay. So basically now we just want to verify on the CLI if everything is intended. Show IP interface brief. Alright, cool. That means the interfaces are set. Show IP protocol. Alright, so basically our BGP is up, and these are our neighbors 51.150.5. And we go to show BGP summary. So yes, you can see that 151.151.5 is up, and the Adjacency has been up for the last 7 minutes. Yeah, 76 minutes, which makes sense because that's when we configured it. Again, let's check IS2. Show IP interface. Show IP protocols. And show BGP summary. Wow, so successfully done. So that's the modern approach of network device configuration. So basically, we're done for today. So next week, I think I wanted to work on BGP prefix advertisement this week. So basically, this approach is because I haven't studied any networking concept, because I primarily focus more on the automation concepts for the past year or so. I just want to go through my basics again just to familiarize before I go into the actual syllabus. Then if we go into the syllabus, I'll always be applying this modern day concept. So expect numerous videos to be coming, unless there's anything that happens. But either way, by God's grace, there'll be so many videos coming. So that will be for configuring different aspects of the router. Also, one working with ISXR. So because I don't really have an image for it, I'll probably have to use the DevNet Sandbox for that. So thank you guys. Subscribe if you like my video, and see you in the next video.